We're into the final question of paper one, question 10. Now, in last year's Leave Insert, you might have seen that question 10 and paper one particularly was the hardest of all the questions, and paper two, similarly, was a tougher question. And sometimes students can have it in their mind that like question 10 is often the most difficult. And in actual fact, it's not the case. So in this particular case, we made the call to make question 10 hopefully one of the more accessible questions. And we think it'll be one of the more popular ones. And what we were hoping with that is students would just remember that for the day of the exam, that if it's not always the case that they get progressively more difficult. So we expect everyone would kind of be familiar, of course, with the, the type of question they see here. So what we have is a solid block of in the shape of a rectangular prism has a base of width x centimeters. The length of the base is 2.5 times the width of the base. The block has a total surface area of 6,480 square centimeters, okay, for total surface area. Show that the height of the block is 6,480 minus 5x squared all over 7x centimeters. Okay. Now, as you know, there's an awful lot of formulae not in the table book that you do need for Leave Insert higher level maths, and surface area and volume of a rectangular prism is one. So you know we have in the tuition center, we have a sheet with those formulae on it. So you can find that on the website and download it at your convenience. Hopefully everyone will still know that the surface area is 2 times the length by the breadth plus 2 times the length by the height plus 2 times the breadth by the height. So in our case, right, we're going to say that the length, depending on which way you want to call it, but we can say that the length is whichever one you want. Like say this guy's the length, this guy's the width, and this guy's the height. So no matter which way you do it, anyway, you're going to have 2 times x times h plus 2 times 2.5 times h plus 2 times 2.5 x times x. So, and that's going to be equal to 6,480. Tidy that all up by multiplying it out, and you're going to get 7xh minus 6,480 minus 5x squared. And of course, now you can see that you're going to get to your answer because you isolate h and you get h is equal to the desired result, 6,480 minus 5x squared all over 7x. And that's 10 marks. And I'd be hoping most students would have got there. However, the key thing again, if somehow you forgot the formula, you didn't get it right, you made a mistake, you can still continue on because you have the answer. So we know we're going to use that. Part one says show the volume can be written as. And they could even say hence show the volume, because the trick is always that you use your answer for h in this next part, because we hopefully all do know that the volume is length by breadth by height. So again, I think if we're going to call this one the length, this one's the breadth, and this is the height. Well, we know now that x is the length, the breadth is 2.5 times x, and the height is h. And when we fill in for h, what we gotten in part A, we can then multiply this out, and the multiplication, again, won't be too difficult. The x's will cancel there. The x below here into one of the x's in the x squared. And then I can multiply through and tidy up. But I suppose there is a little bit about where does the 7 come from, go to, and how does it become a 14? Well, basically, to get rid of the 2.5, I multiplied above and below by 2. And so then I get 5x times 6,480 minus 5x squared over 14. And that is my answer. Now, I was being guided towards it because we could see, I get rid of all this stuff, we could see here that, what was needed inside this bracket was what we had. So the only thing that had to change was the 2.5 and the 7. So again, hopefully you got your way to it. But again, we have our answer here for volume. So any little mistakes, okay, we might have lost a few marks, but you're still able to keep going. Now, B part 2 is one that might have taken a bit of thinking for people, different ways you could do it. Given that Vx is greater than naught, so the volume of the box is greater than naught. Okay, that makes sense, doesn't it? And X is greater than naught, so both the length and then correspondingly the breadth are both greater than naught. Find the possible values for X. So what are we saying here, right? We have our formula for volume in centimeters cubed. We know that this must be greater than naught. So if V is greater than naught, because X is greater than naught, that means 5X is greater than naught. 14 is also greater than naught, of course. So then the 6,480 minus 5X squared, that must also be greater than naught to make the entire thing, the entire function greater than naught. So all we actually have to do is solve this guy. So that mightn't have been apparent straight away to students. However, you could work it out in a more trial and error version as well. So once we get down as far as here, we get x squared is less than 1,296. Square root of both sides, x is less than 36. But to be fully correct, you do have to write your answer like this. X is going to be between 0 and 36, but not including 0 or 36, because in either case, you would get an answer of 0. Okay, so 5 marks for that one. We're then asked to differentiate dv dx. Okay, so get the rate of change of the volume as x changes and get it in a particular form. So, okay, you'd look at this. Your first thought might be quotient rule, but no, you don't need the quotient rule. Once we multiply in through the brackets here, we get 32,240 x over 14 minus 25 x cubed. Sorry, let me say that again. 32,240 x minus 25 x cubed over 14. Because I was preempting what I was about to say. You could divide the 14 into each part there if you want. Or you could think about it as this is like 1 over 14 times 33,240x minus 25x cubed. And if you had it like that, you would probably recognize that the 1 over 14 is just a coefficient of the rest of it, what's in the bracket. So by itself, it's not important. Now, if you apply the quotient rule, you'll find it works out exactly the same. But in this case, it is only the part, the numerator, that really anything's going to happen in, and you're going to apply your rules of differentiation. So 32,240x becomes 32,240. 25x cubed is going to differentiate to be 75x squared. And so that's my answer. And oh yeah, but we have to get it in this form. That's important, isn't it? So you might look at it and think, oh yeah, I have it. And you might even think that that is in that form, but you must get it into the correct form. So it is, even though you might think they're very similar, and they are, they are different. So you've divided 14 into 32,440. And so you end up there, when you do that, it simplifies down to 16,200 over 7. So if you didn't get that and you weren't quite sure, you could just do that in your calculator again. 32,240 divided by 14 will simplify down to that. That is the B in our kind of in what we're directed towards finding. When I divide the 14 into 75x squared and the minus 75x squared, nothing changes there. And that is we'll just say ax squared. Now you might say, well, it doesn't, they're still fractions. But of course, you're told here that a and b are elements of the real numbers. So what's important in terms of getting is, we'll say, to be the correct form, is the fact that there's a plus between the two parts. Okay. So again, I imagine people could have just lost a little bit, a few marks on that part. Okay. In this case, it says, find the exact value for x and h if it is to have a maximum. Now, we know the max occurs where dv dx is equal to 0. So we know what dv dx is. We've already gotten that. Okay, that's what we got there in the last part. So now we're going to have to solve this, right? So we're going to multiply across by 14, divide across by 75, and we're going to get x squared is equal to 432. Okay, so just to be clear what's happening there, it's like if you think about it as a cross multiplication, cross division kind of idea, we're isolating the x squared anyway, and we're going to get the square root of x, which is 12 root 3 centimeters. So x is equal to 12 root 3 centimeters, okay? And that is the exact value. Now, I would be inclined maybe to get the second derivative here as well, and just to be sure, but it's kind of obvious because x is positive value here, that when we differentiate here, we're just going to end up with like minus 75x over 7. This part will be gone. And when you sub in the 12 root 3, you're going to get a negative answer, implying a maximum. However, I'd be inclined just to put it in. You didn't need it in this case, but I'd be inclined to put it in just in case for the leaving cert. So we know what h is. We got that very early on. So now we're going to sub in x for h. And we're going to be careful, particularly with squaring this part out here. That's going to square back out to 432. Multiply that by 5 and take it away from the 6,480, and then divide it by 7 times 12 root 3. And you're going to end up with 120 root 3 over 7. Now, the truth is, most people would put this into the calculator and you will get your correct answer. However, if anything happens that's not working, sometimes the on-time calculator can just go and give you a decimal answer. You just do it out step by step and you will get there. And those are the fully exact answers. Okay, so that was worth 10 marks. All right, so, obviously working it, but we now have the exact value for x that gives you the maximum, and then the exact value for h that gives you the maximum. You can probably see where we're going to go then. Find the maximum value, correct to 2 decimal places. Well, here is our volume. This is just in terms of x. We can sub in our 12 root 3 and work it out. We want to correct to 2 decimal places, so 32,067.68, and it's centimeters cubed. And that was your 5 marks. So that takes us to the end of question 10. And I hope you agree that, while it wasn't simple by any means, it was accessible, I would say. And you could keep going, you could keep going, you could keep going. Even if you were struggling with some parts, you could keep picking up marks. And that takes us to the end of paper 1. So I'd say, well done to everybody. I would ask you to fill in with the link, the survey, so you fill in your results into the portal, because that'll help us to release some summary results to everybody, like what was the best answered question, what was the worst answered question, did people do better on problem solving or skills? And that'll allow you then to analyze your results compared to everybody else, and you'll figure out where you need to improve to maximize your marks in Leaving Cert 2024. Okay, guys, I know I'll see you for paper 2 next week, and I'm sure I'll see most of you for the 21-day maths challenge as well, starting towards the end of May. Okay, I would say, just I suppose yet again, well done to everybody, and I am absolutely 100% certain this will benefit you when you sit down to do your paper in June.